Welcome to Brain Vision.
In this problem, we are asked to compare the high tension in a string to a low tension string. We will write FH, high tension string, using fundamental frequency formula, which is V is equal to frequency is equal to V over 2L. 2L is the length of a string, and then we can write V is square root of the force, tension force, so T over mass density of a string. Combining these two equations, then we can write Ft it will be equal to 4L square density F square pi R square. R is the radius of a string, pi is a constant, F is the frequency, this sign is actually a density of a string, and L is the length. We can write mu, which is a linear mass density, as density times the cross-sectional area, which is a pi R square. So this is the value of a mu in terms of a density and cross-sectional area. So we plug this value here and then solve for Ft. Then we got this formula. So now our job is to compare for high and low tension in a string. We can compare that by comparing the radius, because the densities are same, the frequencies are same, and the lengths are same. So we will write this, our initial formula, as a 4L square times the density times frequency square times pi times R. Now this R corresponds to the string with high tension, so we will write RH square over all of the same values, except here we have R, which is a low, corresponding to low tension in string. Since we have the same thing in denominator and numerator, they will cancel out, so these all will cancel out with the same numbers, which I haven't wrote it here. So they will cancel out each other. So the relationship between FH over FL will be equal to RH square over RL square. We can write RH in terms of a diameters, which is given in a problem. So our FH over FL will become 1 over 2 of a diameter of a string H over 1 over 2 of the diameter of a low tension string square. DH is given in a problem, DL is given in a problem. We will plug those values and simplify. Then the answer we get here is, the ratio we get here between these two forces is 1.70. End of the problem. Thank you for watching.